Hi students, welcome to matrix classes. In this class, we will discuss about logarithmic functions. So first, we start with exponential function because logarithms are inverse of exponential functions. First, we will understand about exponential functions. Any function of the form f of x equals to a power x, where a greater than 0 and a not equal to 1 are called exponential functions. Here a is called base of the exponential function. Now coming to the domain of the exponential function, exponential functions are defined for all real numbers. X value can be any real number. The only thing is base must be a positive quantity. And again, base is not equal to 1. What is the reason? When base value is 1, whatever may be the exponent, the output is always equal to 1. That is why when we are defining exponential functions, we don't consider base 1. Okay. Now coming to the range of the exponential function. Range is only positive real numbers, because when base value is a positive number, positive power anything always becomes a positive number. So that is the reason we have only positive real numbers in the range. Now what are the examples of exponential functions? Suppose f of x equals to 2 power x, 1 by 2 power x, 3 power x, 2 by 3 whole power x. These are all can be considered as exponential functions. Now, coming to the graph of exponential functions, how they look like. Yeah. When base value is greater than 1, exponential function is an increasing function, because when you take f of x equals to 2 power x, 2 power 1, 2 power 2, 2 power 3, 2 power 4, you can see value is increasing. And at the same time, if you take f of x is equal to 1 by 2 power x, then what happens? As base increases, it will become 1 by 2, 1 by 4, 1 by 8. So you can see value is decreasing. So that is why graph of exponential function is different when base value is more than 1, when base value is less than 1. Suppose anything power 0 is 1, when you take this point. Yeah. So this will be the graph of exponential function when base value is more than 1. And you can say it is increasing function. Now coming to base value between 0 to 1, how the graph look like. Yeah, this is how it looks like. So here base value is between 0 and 1. So it is decreasing function. So this is how graph of any exponential function looks like. Okay. Next, we'll go to logarithms. How a logarithm is defined from exponential function. Yeah, logarithmic function. Suppose a power x is equal to some n. From this, you can write x value is equal to log n base a. Here, you can clearly see n value is greater than 0 and a value is greater than 0, because base value must be a positive real number and base value is not equal to 1. So these are the conditions to define a logarithm. Means a logarithm is defined only for positive real numbers with positive base and which is not equal to 1. Suppose y is equal to log x base a. You can define this only under the condition x is greater than 0, a is greater than 0 and a value is not equal to 1. Let us see some examples. Suppose 2 power 3 equal to 8. So from this you can write 3 is equals to log 8 base 2. Okay. And the other example, you have 4 power 3 equal to 64. From this you can write 3 is equal to log 64 base 4. If you take 10 power minus 2, you will get 0.01. How you write this in a logarithmic form? You can write this as minus 2 is equal to log of 0.01 base 10. Okay, so this is how you convert an exponential into logarithm. Now coming to logarithmic function, if you write its domain, so domain is x belongs to 0 to infinity. You can define only for positive real numbers. And what is the range? Range is y belongs to minus infinity to infinity. You can see which is exactly opposite of this. Here domain is all real numbers, range is positive real numbers. So coming to logarithms, domain is positive real numbers, range is all real numbers. And that is why we say logarithm is inverse of exponential functions. And here you have to observe one thing. In logarithms and exponential, base is same. Their base is a. Here also you will have same base. Okay. Now let us see one function. Suppose f of x is equals to log of x minus 2 base 6 minus x. If you want to define this function, you must write x minus 2 greater than 0, 6 minus x greater than 0, and at the same time 6 minus x not equal to 1. So from this you will get x greater than 2. Here you will get 6 greater than x or x less than 6. And here x is not equals to 5. So finally, if you combine all these three, so first one is saying x greater than 2. So right side of 2. Second one is saying x less than 6. So you can say left of 6. Now, what is the combined region? Combined region is between 2 and 6. I can write x belongs to 2 to 6 and 5 is excluded. So I will write minus 5. This is how you find the domain of a logarithmic function. We will see this type of questions when we solve the problems. Now, let us look at the graph of a logarithm. how a logarithmic function looks like. So here also, based on the value of the base, how the logarithmic function looks like will change. Yeah, here it is 1 comma 0. So logarithm of 1 with any base will become 0. So if base value is more than 1, the graph looks like this. So f of x equal to log x base a, where a is greater than 1, and you can see it is increasing function. Now if base value is less than 1, so here base is between 0 and 1. This is how logarithmic function looks like. When base value is more than 1, you can see when base value is more than 1, it is increasing function. When base value is between 0 to 1, it is decreasing function. Okay, so we have seen how to convert an exponential function into a logarithm, and we will see one example where we convert logarithm into exponential. Suppose you have log b base a equal to some n. From this you can write, if you move or if you transfer this base to other side, this logarithmic function will be transformed to an exponential function. Suppose if you have like this, some x. So first you can take this, you can transfer this base to right side. So you will get log b base c equals to a to the power x. Again, if you do the same thing, you can write b is equal to c to the power of a to the power of x. Okay, so this is how you can convert a logarithm into exponential function and exponential into logarithmic function. In this class, we have seen what is the definition of an exponential function, and then what is its domain, range, and how you can draw the graph of an exponential function, how they look like. And next, how to write or how to convert exponential function into a logarithmic function. What is the domain of a logarithmic function, and what is the range, and then how the graph of a logarithmic function looks like. Okay. In next class, we will discuss the properties of logarithms. Okay. Thank you.